Hi there, and welcome back to the concept or the study of equilibrium of particle. But this question here is a past question under the idea of resolution of vector in 2D, right? So let's see how we can solve this question. This question is basically a question under resolution of forces in 2D, right? So what do you do in this case? First, it says find the find the resultant what? Force, resultant angle, resultant direction. Let's see how we can possibly get this man done. First things first. Please, in this diagram here, in this diagram here, I have force one, force two, force three, angle one, angle two, angle three. No problem. So first, define your forces and your angles. So let's say, call it F1. So F1 is 80 Newton. Theta 1 is of course 40 degrees. F2 is of course 120 Newton. Theta 2 is of course, theta 2 is not just 30, but what? The sum of what? 40 with 30 gives you total angle of what? 120. So I'm saying that to get theta 2, simply add 30 degrees plus 40 degrees. That gives you 70 degrees. So theta 2 is 70 degrees. F3 equals to 150 Newton. Theta 3 is equal to 35 degrees. So this is I've defined F1, F2, F. That's the first task. Define each of the forces. F1, F2, F3. Define our angles there. Theta 1, theta 2, and theta 3. Your next task now is to apply the condition of equilibrium, right? So let's apply the conditions of equilibrium to solve this particular question. First, our first condition we know is summation of horizontal components, right? Horizontal component, right? Let's see what this man gives us. That's summation f of x equals 0. This is like the condition of equilibrium that we know. This is it here. So let's apply first condition. So f of x. Please let's resolve. If I resolve 80 Newton to the horizontal, you can see first note that F1, F2, F3 are all inclined to an angle to the horizontal. It means both F1, F2, F3 they will be all cos theta because all the angles are lying on the horizontal. So this F1 here, if I take F1 to the horizontal, that becomes F1 cos theta 1. 120 is F2 to the horizontal, that gives you theta 1 plus F2 cos theta 2, right? If I take F3 to the horizontal, of course to the horizontal, S is negative here. That gives you negative F3 cos theta 3. All right, I have this value here. All right, so let's get summation f of x. From here, summation f of x will be equal to, put in value, what's f1? F1 is 80, theta 1 is 40. That gives you 80 cos 40 plus f2 is 120. So that's 120 cos theta 2 is 70 minus f3. This is minus f3 is 150. That's 150 cos what there? Theta 3. Theta 3 is what? 35. 35. All right. Summation of f of x will now be equal to, if I punch this value, what do we get? If I punch these values, what do we get? Calculator. Let's punch values. What do we get? 80 cos 40. This man gives you 61.28. Next up, plus. Let's get the next one. I have 120 cos 70. 120 cos 70. This man gives you 41.04. Next up, minus. Let's see the value of 150 cos 35. Please, as I'm punching, punch your own too. All right. 150 cos 35. This is of course 122.87. All right, that's the value of this one here. I will work on this one. What do I have there? It means that summation f of x will be equal to, work on this one here, 61.28 plus 41.04 minus 122.87. All right, this one gives about negative 20.55 Newton I. So this is my f of x summation f of x value. Let's get summation f of y. Second condition, summation of vertical component. For this one, that gives you summation f of y equals 0. What do we know? If I resolve f1, f2, f3 to the vertical, it gives me sign. We know that already. And everything will be positive. If I resolve f1 to the vertical, gives me summation f of y, gives me f1 sine theta 1 plus resolve f2 to the vertical. That gives you f2 sine theta 2 plus, you know, we said for second quadrant here, we said if I draw this line this way and I turn this one this way, right? This is my first quadrant, second quadrant. The second quadrant, vertical component, y is positive, x is negative. So y is positive, that's positive f2, f3 sine theta 3. Put in values, what do we get? This gives you summation f of y is now equal to, f1 is what? f1 is 80 sine theta 1 is 40 plus f2 is what? 120 sine theta 2 is of course 70 plus f3, what's f3? 150 sine theta 3 is 35 sine 35. Let's see what we get here. Summation of f of y will be equal to sine, let's see how this value give us. Let's see what this will give us, please. 80 sine 40, 80 sine 40, that's 51.43 plus 120 sine 70, 120 sine 70, that gives you 112.76 plus 150 sine 35, 150 sine 35, that gives you 86.03. Work on this, please. Summation of f of y will be equal in value to, work on this, please. That gives you 51.43 plus 112.76 plus 86.03. That gives you in total 250.22 Newton J. All right, please, we are asked to find resultant force first. So let's get resultant first. We need this value, right? We also need this value to get what we are asked to find, please. All right, let's work on this and get the value of first resultant force, resultant angle, and resultant direction. All right, take this one off. Let me leave the question so we can check back when we need it. So look up, please. From here, we have to find about letter I say find what resultant force. That's the first one. What do we know? F resultant in vector form is equal to summation of f of x I plus summation of f of y j. I've given you this formula in our last classes, so check our video. This one gives you resultant force in vector form is equal to this value, summation of x, what? That's negative 20.55. This is negative, please. Negative. All right. Newton I plus f of y gives you 250.22 Newton J. Newton and Newton is common. Bring it out. That gives you resultant force of this diagram is equal to minus 20.55 I plus 250.22 J. Of course, in a bracket this way, attach your Newton outside. This is the value for resultant force of this particular question. Let's get II and III. All right. All right. Take this one off. All right, from here, proceeding. Let's get III, please. II. For II, what do we have there? For II, okay, that's resultant angle. Let's get resultant angle. That's in bracket theta. We said theta in our last class for this concept is equal to tan inverse of summation f of y over summation f of x. All right. This one gives you theta is equal to tan inverse. So tan inverse of summation f of y. F of y gives you this value. That's 250.22 all over f of x is negative 2.55. All right. At this level in your studying career, at this junction, so at this level in your studying career, you should know some things by now. You should know that negative should not be under the denominator. You should know. So in other words, I'll take it up here. It's possible it's up here. It's okay like this. So you should know this. From here, this gives you theta equal to tan inverse of, divide these two values, that gives you negative something. Negative, divide the value, 250.22 divided by 20.55. 12.1761. All right. So theta is equal to Press shift and tan inverse. So press tan inverse of 12.1761. That gives 85. It's 85 degrees. Okay, it's 5.3 degrees. It's 5.3 okay degrees. All right. But of course, there's negative here. Is negative. But please note that angle cannot be negative. It's just showing this negative. This negative here is telling you that it's facing the negative region of a graph, right? We'll draw the diagram now. You see, so it means that this man is possibly facing negative side. So my angle becomes 85.3 degrees. That's your angle. We have gotten the force, the angle. Please let me attach one to it before the last one. Let's attach one. Before we do the last one, the direction. Before we do the direction of this stuff, let's try to get the magnitude of the resultant force. Let's attach it to it. IV magnitude of resultant force. All right, take this one off. Take this off. All right, let's get IV, which is magnitude of resultant force. So the magnitude of resultant force is given as this. Is equal to what? Square root of summation of f of x square plus summation of f of y square. Let's get this value, please. From here, I have that resultant force, the magnitude of resultant force is equal to the square root of summation f of x. F of x is this value. F of x is this value. That's in bracket 20.55 all square plus into, sorry, it was negative. Yes, negative. It's negative because we shifted negative here up. It was negative, so that's why I have negative this value plus this one here gives you 250.22 all square. All right, if I punch what I have here, punching the square root of this one gives square root of, let me punch this value, the square root of 220.55 square. This one gives you perhaps 422.3025 plus, work on this one here. See, please, the negative here will not affect the stuff. Oh, I've explained this last class in our previous classes. Why, if you have this form, the answer won't be negative. All right, 250.22 all squared. This gives 62610.0484. All right, add them up. This gives square root of, add them up, plus 422.3025. This gives 63032 point, let's say 35. All right, I have it. So the magnitude of resistance force is almost gotten. So take the square root of this answer. Take the square root of the answer. Let's see what we get. Take the square root of the answer. Let's see what we will get. All right, from here, this gives you the magnitude of resistance force will be equal to square root of that value, square root square root of 63 All right, this gives you about 251.06 Newton. All right, this is a value for the magnitude of the resultant force. Finally, let's find direction. We're asked to draw direction like the diagram of that question, right? That's I. So direction gives you for direction, what do we know? First, I have my quadrant this way, right? So what will be direction if I resolve this? If I resolve that question, what will be the direction from the question there? What will be the direction? It's easy as we said. The angle, when we got angle, our angle was what value? If I check very well, when we got angle, what was theta? Theta was negative. Theta was negative. Negative something, right? Am I correct? Yes, negative. Theta was negative. Theta, what's theta here? Let's get theta. Let me check mine. Theta was negative. Theta was negative 85.3 degrees. 31 or 3. 31 or 3. That's what I have there. If I can recall very well. Check your note, please. Confirm this value, please. Theta. Now listen. We said the answer to theta was just only 85.3, right? But initially it's meant to be negative. But because angle cannot be negative, we ignore the minus and put positive value. But yes, I there. The negative means something. It means that the direction of the force is facing towards what? The negative axis. That is, my angle here is negative. It being negative, here is positive of x. Here is what? Negative of x. Negative here tells you that this angle here will be formed at this section. Now, forming this, I'm assuming that this angle here to this place is what? 85.3 degrees. So no need to write minus again. This position here, this quadrant means it is negative already. Then our force, magnitude of the force is what? 251.06 Newton. All right, this is the direction we are asked to find. So this is the direction of the question. All right, this is how you solve this particular question under the concept of applying the idea of resolution of vectors in 2D. All right, see you guys in the next class. If you're also interested in joining my WhatsApp group, I launched my WhatsApp group. In the WhatsApp group, I share content that we are meant to put out on YouTube there. So you'll be the first person to see our new content in the group. Also, opportunities are there in the group, and also you get access to the things I do, right? And also you can get value from them via my status on WhatsApp. So you can message on WhatsApp, you can save a number. So whatever updates, you can see them on WhatsApp status, right? And aside that, you can do it to join the WhatsApp group. From there, you can see my contact from there. Or simply check the screen above, see my WhatsApp number. So I also have some courses that are ready for you. Do well to visit those courses. As this video was playing, I was displaying some stuffs I offer aside teaching you here. So do well to patronize those courses, and then see you guys in our next class. Welcome to Excellent Link Academy. If you found this class helpful, don't like this video, share to your friends, subscribe to my YouTube channel. See you guys in our next video.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen. Alright, guys, you can now join my channel membership to have access to exclusive videos of mine, which most people will not have access to. To get this link, membership program, as you can see the left hand side of the screen, you can see the YX/Jam classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both. Right, so once you join the channel membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner. Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.